In this section, we take stock of the ways that agentic AI systems have the potential to benefit society. First, we consider the ways that a more agentic version of a particular AI system might be more beneficial than a less agentic version, agenticness as a helpful property. Second, we consider the ways in which agenticness can enable wider diffusion of AI in beneficial applications in society, and is often implicit in many definitions of and visions for AI, agenticness as an impact multiplier. While our discussion in this section is brief, this should not be read as an indication that the list of possible benefits is necessarily short or that the magnitude of those benefits is small. Nor do we make claims that the benefits clearly outweigh the risks, or vice versa. 3.1. Agenticness as a helpful property. Specific AI systems may in many cases be more beneficial in proportion to the extent to which they are agentic, provided they are designed safely and that appropriate best practices for safety and accountability are applied. Agenticness can make a particular system more beneficial in ways such as the following: higher quality and more reliable outputs. For example, a language model that is capable of browsing the internet autonomously and revising its queries in response to the results it receives may be capable of providing much more accurate answers to questions than a system that is not able to do so. This may be particularly true in instances involving topics that are dynamic in nature or events that occurred after the underlying model was trained. More efficient use of users' time. For example, if a user provides high-level instructions to an AI system regarding code they want the system to produce, it may be smoother for the user if the system performs several steps autonomously. G. Translating the instructions into code, running the code, displaying the results, assessing those results, and making edits to the code in order to improve outcomes. Improved user preference solicitation. For example, personal assistant AI that is capable of interactively sending messages to its users in order to ask clarifying questions in natural language, and that does so at strategically appropriate times, may provide a better experience than an app with numerous complex configurations that is difficult for users to leverage effectively. Scalability. An agentic AI system may allow a single user to take many more actions than they could otherwise, or be capable of benefiting a much larger number of people than a less agentic version of the same system. Consider the example of radiology. A non-agentic radiology image classification tool may be helpful for making a radiologist slightly more efficient, but an agentic radiology tool that was capable of completing certain patient care tasks without human supervision, e.g. compiling reports on the scan, asking patients basic follow-up questions, could potentially increase a radiologist's efficiency substantially and leave more time for seeing many more patients. 3.2. Agenticness as an impact multiplier. In addition to analyzing the implications of agenticness in the context of particular AI systems, one can also view agenticness as a prerequisite for some of the wider systemic impacts that many expect from the diffusion of AI, some of which have significant potential to benefit society. Insofar as agenticness is a definitional or practical prerequisite for that diffusion, the impacts of agenticness may be closely related to the impacts of AI more generally. In this sense, the impacts of AI generally are likely to be more frequent and more pronounced, and to happen sooner, to the extent that agenticness increases, making agenticness an impact multiplier of the field of AI as a whole. Sometimes agenticness is implicitly assumed when people talk about current or future AI capabilities. OpenAI's charter defines artificial general intelligence, AGI, as highly autonomous systems that outperform humans at most economically valuable work. And canonical textbooks, such as Russell and Norvig's Artificial Intelligence, A Modern Approach, emphasize agenticness in their conception of AI. Given these considerations, we briefly review several commonly expected impacts of AI as an overall technological field. Even without significant further advances in agenticness, AI is likely to already constitute a general-purpose technology. Historically, the widespread adoption of general-purpose technologies, such as the steam engine and electricity, has vastly increased the global standard of living over time, though also brought about significant harm for many, and in particular for less powerful or privileged groups living through those periods. Highly capable and agentic AI systems that are widely deployed could even improve economic productivity so much that they fundamentally change the nature of work, potentially, and perhaps more speculatively, enabling a leisure society or post-work world, though this is by no means guaranteed and would carry risks. Additionally, AI could accelerate progress on various non-economic measures of societal well-being, such as those encapsulated in the Sustainable Development Goals, and by accelerating scientific progress and understanding. The economic and other productivity gains some expect from AI may be greater to the extent that agentic AI systems are able to take actions autonomously.